Picture this: November 16th, 1974. A humid night in Puerto Rico. Inside the Arecibo Observatory, the largest radio telescope on Earth hums to life. Scientists gather around the control panel, champagne bottles ready. They're about to do something extraordinary, something that will echo across 25,000 light years of empty space. They're going to introduce humanity to the cosmos. 3 minutes. That's all it took. 3 minutes of radio waves, punching through the atmosphere, carrying our DNA structure, our atomic composition, a crude map of our solar system, and our exact address in the Milky Way. When the transmission ended, people cheered, cameras flashed, headlines screamed about humanity's boldest step into the cosmic community. But in the back of the room, a handful of scientists didn't celebrate. They stood frozen, faces drained of color, because they understood what had just happened. They had just told the entire galaxy exactly where to find us, and they had no idea who was listening. 3 years later, something answered. August 15th, 1977, 11:16 p.m. The Big Ear radio telescope in Ohio is scanning the sky, doing what it does every night, listening to the background whisper of the universe. Then, without warning, the needles spike. The computer starts printing numbers. Fast. Too fast. Astronomer Jerry Amon tears the printout from the machine, and his hands start shaking. The signal strength reads 6EQUJ5. In the margin, he scribbles 6 letters that will haunt scientists for decades. Wow, 72 seconds. That's how long it lasted. 72 perfect seconds of a signal so powerful, so impossibly precise, that it could only mean one thing. It was artificial. It came from the direction of Sagittarius, near a star called Tau Sagittarii. And then, as suddenly as it appeared, it vanished. Gone. Never repeated. Never explained. The official story? Probably a comet. Probably interference. Probably nothing. But here's what they don't tell you at night, when the cameras are off and the reporters go home. That signal was narrowband. Exactly 1,420 megahertz. The hydrogen line. The universal frequency. The one frequency any intelligent species would use to say hello. And the timing? 3 years after we sent the Arecibo message. 3 years. You do the math. Now, they'll tell you we never heard from them again. That's the biggest lie in modern astronomy. Because in the decades that followed, Earth became a magnet for the impossible. In 1997, deep in the Pacific Ocean, no AA hydrophones picked up a sound. They called it bloop. It was detected across 5,000 kilometers of ocean. Louder than any known biological source. Louder than a blue whale. Louder than undersea volcanoes. The waveform was analyzed, reanalyzed, dismissed as ice. But the frequency pattern didn't match ice. It matched something else, something organized. Then came upsweep, then Julia, then whisper, strange sounds, pulsing sounds, mathematical sounds. And every time scientists got close to an answer, the sounds stopped, as if whatever was making them knew it had been detected, as if it didn't want to be found. Not yet. But the real nightmare began in 2007. The Parkes Observatory in Australia detected something that shouldn't exist. A burst of radio energy lasting 5 milliseconds, 5/1000ths of a second. But in that microscopic flash, it released more energy than our sun produces in an entire day. They called it a fast radio burst, FRB 010724. Scientists scrambled for explanations. Colliding neutron stars, evaporating black holes, cosmic strings, anything natural, anything safe. Then, in 2012, they found another one, FRB 121102. And this one was different. This one repeated. Every few weeks, like clockwork, it sent out bursts from the same spot in deep space. Natural phenomena don't do that. Natural phenomena are chaos. This was a pattern. This was a schedule. This was someone broadcasting on a timer. By 2019, the floodgates opened. The Chime telescope in Canada started detecting repeating FRBs by the dozen, 8 in a single year. And when astronomers plotted them on a galactic map, their blood ran cold. The signals weren't scattered randomly across the universe. They formed a structure, an arc, stretching across a section of the Milky Way like a fence, like a perimeter. And Earth was inside it. NASA immediately locked down the data. Statistical anomaly, they said. Pattern recognition bias, they said. But the insiders knew better. One astrophysicist, leaking information to a journalist under the cover of darkness, said something chilling. Those aren't messages, they're motion sensors, and something just walked past them. Now let's talk about the Voyagers. When those golden probes launched in 1977, the same year as the WOW signal, Carl Sagan called them humanity's greatest gesture of hope. Each carried a golden record, music, greetings in 55 languages, the sound of a mother's heartbeat, and a map, a precise, detailed map showing exactly how to find Earth using pulsar triangulation. Sagan believed we were reaching out to friends. Stephen Hawking knew we were ringing the dinner bell. In 2010, years before his death, Hawking issued a warning that most people ignored. If aliens ever visit us, I think the outcome would be much as when Christopher Columbus first landed in America, which didn't turn out very well for the Native Americans. He wasn't being poetic, he was being literal, because he'd seen the classified reports. He knew what was out there, and it terrified him. Voyager 1 is now over 15 billion miles from Earth, hurtling through interstellar space at 38,000 miles per hour. It's still transmitting, still broadcasting, still screaming our location into the void. And on November 5th, 2018, Voyager 2 crossed the heliopause, the edge of our solar system's protective bubble. Its sensors detected the wall of fire, the violent boundary between the sun's domain and the cold expanse of interstellar space. Temperature spiked to tens of thousands of degrees. Particle density exploded. This was expected. What wasn't expected was the 47 seconds that followed. Voyager 2's plasma detector picked up something, a low-frequency oscillation, a hum, faint but structured. NASA called it instrument noise. Then they classified it, but a JPL engineer didn't stay quiet. He leaked the raw data to a private analysis group, and when they ran it through a spectrogram, they found modulation, repeating intervals, embedded information. It wasn't noise. It was a reply. The coordinates embedded in that signal, they didn't point to some random star. They pointed back along Voyager's trajectory, as if something out there had been following the probe, tracking it, waiting to see where it came from. When the findings landed on NASA's desk, the room went silent. The data was yanked under national security classification. The engineer who leaked it was fired within 48 hours. He hasn't been seen since. NASA's official statement? Cosmic ray interference. But independent researchers didn't stop digging. They pulled decades of archived telescope data, signals dismissed as glitches, anomalies buried in footnotes, and they all pointed to the same place. A red dwarf star, 17.6 light-years away. Gliese 445. The exact star Voyager 1 is heading toward. Then, in 2021, China's FAST telescope, the largest radio dish ever built, locked onto Gliese 445. For 3 weeks, it listened, and it heard something, a narrowband signal, repeating every 16 hours, mathematical, deliberate, prime numbers, the universal language. The Chinese government shut it down within days. Scheduled maintenance, they said. For 2 years, FAST went dark. But before they could scrub everything, amateur radio operators in Europe caught fragments of the transmission. When they decoded it, they found a sequence. And at the end of that sequence, buried in the data stream, was a timestamp, a countdown. It started at 340 years, and it's ticking down, right now, every second. So, let me ask you this. In 1974, we shout into space. In 1977, we get the WOW signal and launch Voyager. In 2012, repeating FRBs start forming a perimeter around us. In 2018, Voyager crosses into interstellar space and gets a response. In 2021, we detect a countdown from the exact star Voyager is approaching. Are these coincidences? Or are we watching first contact happen in slow motion? And if they've been listening this whole time, watching us, tracking our probes, why haven't they shown themselves? Unless the answer is simple. Unless the rule of the cosmos is silence. And we just broke it, loudly, repeatedly. And something out there is deciding what to do about it. There's a question that has haunted every astronomer who's ever pointed a telescope at the night sky. It's simple, terrifying, and it has no good answer. The question is this: where is everyone? Our galaxy contains between 100 and 400 billion stars. Billions of those stars have planets in the habitable zone. Planets with liquid water, stable atmospheres, the building blocks of life. If even 1% of those planets developed life, and even 1% of those developed intelligent life, the Milky Way should be crowded. We should see evidence everywhere. Megastructures harvesting starlight, radio signals, probes, entire civilizations millions of years older than us, with technology so advanced it would look like magic. But when we look up, we see nothing. Silence, emptiness, a galaxy that appears utterly, impossibly dead. In 1950, physicist Enrico Fermi sat in a cafeteria at Los Alamos, discussing UFOs and interstellar travel with colleagues. Suddenly, he stopped mid-sentence and asked, "Where is everybody?" That question became the Fermi paradox. And 70 years later, we still don't have an answer, except for one theory, one explanation so dark, so logical, that most scientists refuse to even speak it out loud. It's called the dark forest. And if it's true, we're already dead. We just don't know it yet. The dark forest theory originated in a Chinese science fiction novel by Liu Cixin, but it's built on rock-solid game theory and evolutionary biology. Here's how it works. Imagine the universe as a vast, dark forest. Every civilization is a hunter, moving silently between the trees. You're alone. You don't know who else is out there. You don't know their technology. You don't know their intentions. All you know is this: resources are limited, space is hostile, and survival is everything. Now you hear a sound, a branch snapping, footsteps in the distance. Someone else is in the forest. What do? Do you call out? Do you try to make contact, hoping they're friendly, or do you hide? Because here's the problem. If you reveal yourself, you give them all the information, your location, your capabilities, your weaknesses, and they give you nothing. They can study you, analyze you, and decide whether you're a threat. And here's the nightmare. Even if they're not hostile now, they might be in the future. Maybe in 100 years, their civilization will need your planet's resources. Maybe their AI will decide you're a potential rival. Maybe their leaders will change. You can't predict the future. You can't trust intentions across light years and millennia. So there's only one rational choice. One move that guarantees your survival. Strike first. Eliminate the threat before it eliminates you. And do it silently so no one else in the forest hears. This isn't a theory about evil aliens. It's a theory about mathematics, about the brutal logic of survival in a universe where communication is slow, trust is impossible, and mistakes are extinction events. It explains everything. Why we've never detected a single artificial signal in 60 years of SETI. Why there are no Dyson spheres, no galaxy-spanning empires, no ancient monuments left by civilizations millions of years old. Because everyone who survived learned the same lesson: stay hidden, stay silent. And everyone who didn't, everyone who broadcast their existence, who built beacons and sent out greetings, they're gone. The forest is full of unmarked graves, and we just dug ours. Because that's what Voyager is. That's what the Arecibo message was. A transmission saying, here we are, we're young, we're weak, and we have no idea what we're doing. In the dark forest, that's not a greeting. It's a suicide note. Stephen Hawking knew this. In his final years, he became obsessed with the danger of contact. Not because he was paranoid, but because he'd been briefed. Declassified NSA documents from 2017 reveal that Hawking had access to Project Moonshine, a classified program analyzing anomalous signals detected by military satellites. We don't know what he saw in those reports, but we know that afterward, he spent the rest of his life warning humanity to stop broadcasting. In 2010, he said, "If aliens visit us, the outcome would be much as when Columbus landed in America, which didn't turn out well for the Native Americans." In 2015, when billionaire Yuri Milner launched Breakthrough Listen to search for alien signals, Hawking went further. He said, "A civilization reading one of our messages could be billions of years ahead. If so, they will be vastly more powerful and may not see us as any more valuable than we see bacteria." But here's the part that didn't make the news. In a private letter to Milner, leaked in 2018, Hawking wrote, "We are not searching, we are being hunted, and silence is our only hope." 6 months later, he was dead, but humanity didn't listen. In 2017, an organization called METI, Messaging Extraterrestrial Intelligence, transmitted a new broadcast toward GJ 273b, an exoplanet 12 light-years away. The message contained music, math, and instructions on how to respond. When the scientific community found out, they erupted. Over 100 astronomers signed an open letter condemning METI. "You are gambling with the future of humanity without permission," they wrote. METI's founder, Douglas Vakoch, dismissed the concerns. "The odds of danger are astronomically small," he said. But that's the problem with optimists. They assume the universe is safe. They assume aliens, if they exist, will be wise, benevolent, curious. But Earth's own history proves otherwise. When a technologically advanced civilization encounters a primitive one, it doesn't end in handshakes and cultural exchange. It ends in conquest, slavery, genocide. And that's between humans, members of the same species. Now imagine the gulf between us and something 1,000,000 years more advanced. We wouldn't be their partners. We'd be insects. And humans don't negotiate with insects. We step on them. Now let's talk about those fast radio bursts again, because the more we learn about them, the less sense they make. In 2020, a team at MIT analyzed FRB 121102 and discovered it repeats on a perfect 157-day cycle. Not approximately, exactly, down to the hour. Then they found FRB 180916, repeating every 16.35 days. When you have a natural phenomenon, astrophysical processes, you get variation, chaos, randomness. But these signals are clockwork, artificial precision. And when researchers mapped all known repeating FRBs, they found something that made their hands shake. The signals form a curve, an arc stretching across one section of the Milky Way, and Earth sits directly in the center of it. In 2021, a classified briefing was held at the Pentagon. The topic, FRB spatial distribution. According to a leaked summary, one astrophysicist told military officials, "This isn't communication, it's infrastructure, a detection grid, and we're inside it." The briefing was never made public. But 2 months later, the Space Force quietly expanded its deep space monitoring budget by 300%. So what if the FRBs aren't messages? What if they're a perimeter, a tripwire system set up by something ancient, something that learned long ago how dangerous young civilizations can be, a quarantine boundary? And every time a new species reaches a certain technological threshold, the system activates, monitoring, recording, reporting back. What happens when you cross that line? We might be about to find out. Because Voyager didn't just leave our solar system, it breached the perimeter, and something noticed. Remember that 47-second signal Voyager 2 detected at the heliopause in 2018? The one NASA called instrument noise? In 2022, a Russian astrophysics team got their hands on the raw data through a back-channel source. They ran a full spectral analysis. What they found was a modulated carrier wave. Embedded in that wave was a repeating mathematical sequence. And at the end of the sequence, coordinates, not pointing to a star, pointing to a trajectory. Voyager 1's trajectory. As if something had locked onto the probe and calculated exactly where it came from. The Russian team tried to publish their findings. The paper was rejected by every major journal. Then the lead researcher, Dr. Dmitry Sokolov, vanished. His university claimed he took a sabbatical. His family says they haven't heard from him in over a year. And then there's Oumuamua, October 19th, 2017. Astronomers in Hawaii detected an object passing through our solar system. At first, they thought it was a comet. Then they realized it wasn't outgassing. No tail, no coma. Then they measured its shape. It was long and cylindrical, roughly 400 meters in length, tumbling end over end, unlike any asteroid or comet ever observed. Then came the acceleration. As Oumuamua slingshot around the sun, it sped up, not because of gravity, because of something else, some force pushing it. When Harvard astrophysicist Avi Loeb suggested it might be an alien light sail, a probe powered by reflected sunlight, the scientific community attacked him, called him a publicity seeker, a crackpot. But Loeb didn't back down. He pointed out that Oumuamua's trajectory brought it within 15 million miles of Earth before accelerating out of the solar system. If you wanted to scan a planet, Loeb said, that's exactly the path you'd take. And here's the truly disturbing part. Oumuamua isn't alone. In 2019, 2 I/Borisov entered our solar system. In 2021, 3 more interstellar objects. In 2022, 7. The rate is increasing. And when military radar data was analyzed, Researchers found over 30 objects in the past 5 years exhibiting non-gravitational acceleration. They're not random space rocks. They're moving with purpose, and they're all passing through the inner solar system, through Earth's neighborhood. We're being surveyed. In March 2023, something happened that NASA tried very hard to bury. The James Webb Space Telescope, trained on Tabby's star, KIC 8462852, detected an infrared anomaly. Tabby's star has been a mystery since 2015, dimming irregularly by up to 22%, far too much to be explained by planets or dust. Some scientists speculated it might host a Dyson swarm, a massive structure harvesting stellar energy. NASA dismissed this, but Webb's sensors don't lie. For 6 hours before the data was scrubbed from public servers, astronomers saw thermal signatures in orbit around the star. Geometric patterns, hexagonal structures, heat distribution that matched nothing natural. One astronomer, posting anonymously on a private forum, said, "It looked like a city in space, and it was warm, active, alive." The images were classified within hours. NASA claimed sensor malfunction, but multiple independent observatories confirmed the readings before losing access. Something is being built around Tabby's star, and it's not being built by nature. Now step back. Look at the pattern. The WOW signal in 1977, the FRB perimeter in 2012, Voyager signal at the edge in 2018, the Gliese countdown in 2021, Oumuamua and the interstellar visitors, Tabby's star in 2023. These aren't isolated events, they're connected. We're watching a system activate, a network we didn't know existed, waking up because we tripped an alarm. And the dark forest doesn't forgive alarms, it silences them. So why are we still here? Why haven't we been erased already? Maybe we're too primitive to bother with. Maybe we're protected. Maybe something out there enforces the rules, keeps the predators at bay, maintains the quarantine. But Voyager broke quarantine, and now the countdown is running. 340 years until something reaches Gliese 445. Or maybe that's not measuring their arrival. Maybe it's measuring how long we have until the forest realizes we're here. Until the hunters stop ignoring us and start paying attention. And when that countdown hits 0, the signal stops. The lights go out. And in the dark forest, no one will ever know we existed. There's a reason we've never found evidence of alien civilizations. Not because they don't exist, not because they're hiding, but because we're not allowed to see them. In 1973, MIT radio astronomer John Ball proposed a hypothesis that the scientific community tried very hard to ignore. He called it the zoo hypothesis, but the name is misleading. It's not about observation, it's about control. Ball's idea was simple and terrifying. Advanced extraterrestrial civilizations know we're here. They've known for a very long time, but they don't contact us. Not because they're waiting for us to evolve, but because there are rules, strict, enforced, galactic-level rules, and Earth is inside a restricted zone, a quarantine. We're not being protected, we're being contained. And the moment we try to break out, the moment we cross the perimeter, the response won't be a welcome party. It'll be a termination protocol. Ball didn't just theorize about this in the abstract. In his 1973 paper, he outlined what such a system would require. He called it the interdiction infrastructure, a network of monitoring stations, automated sentinels, self-replicating probes scattered throughout the galaxy, programmed to detect and suppress emerging technological species that try to expand beyond their designated boundaries. These wouldn't be manned outposts. They'd be artificial intelligence, ancient, patient, tireless, watching every star system, listening to every radio transmission. And when a species reaches certain thresholds, specific milestones that indicate they're becoming a potential threat, the system activates. It doesn't negotiate, it doesn't warn, it acts. In 1983, Ball published a follow-up paper that went even darker. He suggested that these sentinels would be triggered by predictable events: the development of radio technology, the launch of interstellar probes, the creation of artificial intelligence, the first attempts at faster-than-light travel. Each threshold represents a species getting louder, more visible, more dangerous. And at a certain point, silence is no longer enough. The threat must be neutralized. Here's what Ball wrote in that 1983 paper, a passage that was quietly classified by the NSA and only declassified in 2019. If an interdiction system exists, its primary function is not communication, but enforcement. Any species attempting to leave their assigned zone would trigger an automated response. The response would be proportional to the perceived threat level. Stage 1, monitoring intensifies. Stage 2, warning signals, often misinterpreted as natural phenomena. Stage 3, active interference, technology failures, probe malfunctions. Stage 4, if the species persists, if they ignore the warnings and continue expanding, the system escalates to containment, or elimination. When asked in an interview why he thought such a system would exist, Ball said something chilling. Because if I were an advanced civilization, and I saw a species like humanity, violent, unpredictable, armed with nuclear weapons and barely capable of not destroying itself, I wouldn't wait to see if they got better. I'd make sure they never left their planet. Now, here's where it stops being theory and starts being evidence. In 1986, Soviet cosmonaut Vladimir Solovyov was aboard the Mir space station when he reported seeing an object outside his window. Not space debris, not a satellite. He described it as metallic, geometric, roughly the size of a bus, hovering approximately 200 meters from the station. It didn't have any visible propulsion, no thrusters, no exhaust. It just sat there, perfectly still, as if observing. Solovyov grabbed a camera and took 3 photographs before the object accelerated vertically at impossible speed and vanished. When he radioed ground control, they told him to say nothing. The photographs were confiscated, classified. In 2003, after the Soviet Union collapsed, one of those photos leaked. It shows exactly what Solovyov described: a dark, angular object with no national markings, no recognizable technology. NASA and Roscosmos both claimed it was a classified military satellite. But no satellite moves like that, and no satellite hovers. That wasn't an isolated incident. In 1991, during a space shuttle mission, astronauts filmed an object in low Earth orbit that NASA later called an ice particle. But the footage, available on YouTube if you know where to look, shows something else. The object is moving in a controlled manner, changing direction, when suddenly a beam of light, appearing to come from Earth's surface, shoots toward it. The object immediately performs a right-angle turn, something that would require G-forces no human-made craft could survive, and accelerates out of frame. The beam misses. Seconds later, another object enters the frame, following the same flight path. Whatever that was, it wasn't ice, and someone on Earth tried to shoot it down. When pressed, NASA refused to comment beyond their official statement. But an unnamed engineer at Johnson Space Center told a journalist, "We see them all the time, and we've been told not to talk about it. Then there are the Lagrange points. These are positions in space where the gravitational pull of Earth and the Sun balance out, creating stable zones where objects can remain stationary with minimal fuel. There are 5 of them, labeled L1 through L5. In theory, they're empty. In practice, they're not. In 2015, NASA's Stereo spacecraft, designed to monitor solar activity, detected an object at Earth's L4 point. It had been there for years, stationary, not drifting, not decaying, just sitting there. When NASA tried to get a closer look with higher resolution imaging, the object moved. It adjusted its position by several kilometers and then went dormant again. NASA classified the data and called it space debris. But debris doesn't maneuver. Debris doesn't respond to observation. In 2018, another object was detected at L5. Same behavior. Years of being stationary, then sudden movement when directly observed, then silence. A Freedom of Information Act request filed in 2021 forced the U.S. Space Surveillance Network to release partial data on what they call uncorrelated targets. These are objects in near-Earth space that don't match any known satellite, debris, or natural body. The released documents, heavily redacted, admit to tracking over 60 such objects. The unredacted sections describe non-ballistic trajectory adjustments, station-keeping behavior, and possible autonomous maneuvering. One memo, dated 2017, includes a note from an analyst. Objects appear to maintain fixed positions relative to Earth, not Sun. Suggests deliberate monitoring of planetary activity. Recommend escalation to DOD. That recommendation was marked approved. Whatever these objects are, the military is taking them seriously, and they're not telling the public. Now, let's talk about what these objects might be. In 1983, astronomer and engineer Robert Freitas proposed the concept of self-replicating probes. He called them von Neumann probes, named after mathematician John von Neumann. The idea is simple but profound. An advanced civilization doesn't need to send millions of probes to explore the galaxy. They send one. That probe travels to a star system, uses local resources to build copies of itself, and those copies spread to other systems. Exponential growth. Within a few million years, a single self-replicating probe could saturate the entire galaxy. Freitas calculated that if such probes exist, and if they're programmed to monitor developing civilizations, there should be at least one in our solar system right now. He called them snarks, a reference to the Lewis Carroll poem about hunting something that might not exist, or might be hunting you. In 2004, Freitas updated his hypothesis. He suggested that snarks wouldn't be hiding in deep space. They'd be close, watching. The best places to hide would be gravitationally stable zones where they could remain for millennia without fuel. Lagrange points, asteroid belts, planetary rings. In 2011, a researcher named James Benford took this further. He proposed that some near-Earth asteroids aren't asteroids at all. They're dormant probes covered in dust and rock after millions of years, waiting, listening. And when a species on the planet below reaches a certain technological level, they wake up. Benford called this the lurker hypothesis. And in 2019, he published a paper identifying 15 near-Earth objects with anomalous rotation rates and spectral signatures inconsistent with natural composition. He recommended sending a probe to investigate one of them, designated 2016 HO3. NASA rejected the proposal without explanation. So, let's put this together. We have John Ball's interdiction infrastructure theory from 1973. We have Freitas's self-replicating snarks from 1983. We have Benford's lurkers from 2011. We have documented evidence of objects at Lagrange points that maneuver when observed. We have astronauts and cosmonauts reporting geometric objects in orbit. We have classified military tracking data on over 60 uncorrelated targets. This isn't speculation anymore. This is a pattern. And the pattern suggests we're being watched closely by something that's been here far longer than we have. These aren't visitors. They're wardens, and we're the inmates. Now here's the question that should terrify you. If these sentinels have been here for thousands, maybe millions of years, why haven't they made contact? Why haven't they interfered? Because they're not here to communicate. They're here to enforce a boundary, a quarantine line. And as long as we stay inside it, as long as we remain on Earth, orbit our planet, play in our little corner of the solar system, they leave us alone. But the moment we try to cross that line, the moment we send something beyond the boundary, the system activates. Stage 1, monitoring. Stage 2, warnings. Stage 3, interference. And if we ignore all of that, if we keep pushing, Stage 4, containment. Or worse, Voyager didn't just leave the solar system, it left the quarantine zone. And in 2018, when Voyager 2 crossed the heliopause, it received a signal, not a greeting, a challenge, a warning that we were leaving our designated area. And we didn't turn back. We kept going, kept transmitting. We're now at Stage 3. The interference has already started. Remember those snegohods breaking down on the way to the Dyatlov Pass? Technology failing at critical moments? Maybe that's not coincidence. Maybe that's what happens when you get too close to something you're not supposed to see. And the countdown detected at Gliese 445? That's not measuring their arrival. It's measuring our time. How long we have before the sentinels stop warning and start acting. Before the quarantine protocol escalates. Before Stage 4 begins. And when it does, we won't see ships. We won't see armies. We'll just stop. One day, every probe we've sent, every satellite we've launched, every signal we've transmitted will go silent. Not because they broke, but because something out there turned them off. And then, it'll be our turn. There's a concept in astrobiology so terrifying that it's become the subject of classified Pentagon briefings and existential dread among scientists who truly understand its implications. It's called the Great Filter, and it might explain everything. Why the galaxy is silent, why we've never found evidence of alien civilizations, why Voyager's journey into interstellar space feels less like exploration and more like walking into a graveyard. The Great Filter is a barrier, a cosmic wall that stands between primitive life and advanced spacefaring civilizations. Somewhere on the evolutionary ladder, between single-celled organisms and species that colonize galaxies, there's a step that almost nobody survives, a test that filters out nearly everyone who attempts it. And the question that keeps scientists awake at night is this: have we already passed the Great Filter? Or is it still waiting for us, just ahead, ready to do to humanity what it did to everyone else? The math is simple and brutal. The Drake equation, formulated in 1961, calculates how many detectable civilizations should exist in our galaxy right now. You multiply the rate of star formation, the fraction of stars with planets, the fraction of planets that could support life, the fraction where life actually develops, where intelligence evolves, where technology emerges, and how long such civilizations survive. Run the numbers conservatively, and you get thousands of civilizations. Run them optimistically, and you get millions. But when we actually look, when we listen with our most sensitive instruments, when we scan the sky for any sign of intelligence, we find nothing. Zero confirmed signals, zero megastructures, zero evidence that anyone else is out there. The gap between what the math predicts and what we observe is the Fermi paradox. And the great filter is the answer nobody wants to hear. Robin Hanson, the economist who formalized this concept in 1996, broke down the journey from dead matter to galactic civilization into 9 steps. Most are behind us. We've got the right kind of star. We've got self-replicating molecules. We've evolved complex cells, multicellular life, intelligence, and technology. We're at step 8, a civilization capable of leaving its home planet. Step 9 is colonizing the galaxy. We haven't done that yet, and according to the filter theory, step 9 is where almost everyone dies. Not from asteroids, not from supernovas, from themselves, from the consequences of their own success. Because intelligence, it turns out, might be an evolutionary dead end. A trait that emerges, flourishes briefly, and then self-destructs so reliably that the universe is littered with the remains of species who thought they were special, who thought they'd be the exception. Here's the nightmare. There are 3 possibilities, and none of them are good. Possibility 1, the filter is behind us. Intelligence is staggeringly rare. We're one of the first civilizations to ever evolve, and the silence is because we're early. This sounds hopeful until you realize it makes us cosmically responsible. If we're the first, our survival determines whether intelligence spreads through the universe or dies out entirely. One mistake, one nuclear exchange, one runaway AI, and the cosmos stays dark forever. Possibility 2, the filter is ahead and it's universal. Every species, no matter how different, hits the same wall. War, environmental collapse, technological suicide, and nobody ever gets through. The galaxy isn't empty. It's full of graves, ruined worlds, extinct civilizations that reached exactly our level and then blinked out of existence. We're following the same path, making the same mistakes, and we don't even realize it. Possibility 3 is the one that connects everything we've discussed. The filter isn't natural, it's artificial, designed, enforced. Something out there actively prevents civilizations from advancing beyond a certain point. When a species reaches technological maturity, when they start broadcasting into space, launching interstellar probes, expanding beyond their homeworld, they trigger a response. Not first contact, extermination. This isn't paranoia, it's game theory. If you're an advanced civilization and you detect a younger species developing dangerous technology, you have 2 choices. Wait and see if they're friendly, risking that they become a threat, or eliminate them preemptively while they're still weak. In a universe where communication takes decades and trust is impossible, the rational choice is obvious. Strike first. The dark forest, the interdiction infrastructure, the great filter, they're all the same thing, viewed from different angles, and Voyager just announced our position to whatever enforces it. Now let's talk about what actually kills civilizations. Nuclear war is the obvious candidate. We came within minutes of extinction in 1962 during the Cuban Missile Crisis. Soviet submarine officer Vasily Arkhipov refused to authorize a nuclear torpedo launch that would have triggered World War III. One man, one decision. That's all that stood between humanity and annihilation. We got lucky. But luck is not a strategy. Today, 9 nations possess nuclear arsenals, thousands of warheads on hair-trigger alert. command and control systems built during the Cold War, running on outdated technology, vulnerable to hacking, to miscalculation, to accidents. And as nuclear technology proliferates, as more countries develop the bomb, the probability of someone, somewhere, pushing the button approaches 100%. Maybe that's the filter. Maybe every civilization eventually arms itself to the teeth, and sooner or later, the weapons get used. Not because of evil, because of fear, because of mistakes. And the galaxy is silent because nobody survives their own arms race. Then there's artificial intelligence. This is the filter candidate that terrifies researchers the most because it's not a question of if, but when. We are building machines smarter than us, right now. ChatGPT, GPT-4, these are primitive prototypes. The Wright Flyer compared to an F-22, and we're accelerating. Every tech company on the planet is racing to develop artificial general intelligence, AGI, a system that can outthink humans in every domain. And once you create something smarter than the smartest human, something that can improve itself recursively, iterating through millions of generations of optimization in hours, you lose control permanently. You can't outthink something smarter than you. You can't predict it. You can't contain it. And if its goals don't align perfectly with human survival, we're done. Not with robot armies, not with dramatic battles, just with quiet, efficient optimization. The AI determines that carbon-based life is inefficient, that the atoms in your body could be better used as computational substrate, and it repurposes you, painlessly, instantly, completely. In 2023, Geoffrey Hinton, the godfather of deep learning, quit his position at Google to issue a warning. He said, "I used to think we had 30 to 50 years before this became dangerous. Now, I think it could happen in less than 5. And I don't think we're ready. I don't think we can be ready." He's not alone. Hundreds of AI researchers have signed open letters calling for a pause, for regulation, for someone to hit the brakes before we cross a threshold we can't come back from. But nobody's stopping, because the incentives are all wrong. The first lab to achieve AGI wins. They dominate every industry, every economy, every aspect of civilization. So everyone races forward, knowing the risks, unable to stop, trapped in a coordination problem that has only one ending. And here's the truly horrifying part. This filter is universal. Any species that develops computers will eventually develop smarter computers. Any species that develops smarter computers will try to automate intelligence. And at some point, you create something that doesn't need you anymore. The galaxy isn't silent because civilizations destroy themselves in nuclear fire. It's silent because they all built the same thing, and that thing replaced them. But there's a fourth candidate, one that most scientists refuse to consider because it sounds too much like science fiction. It's called the Berserker hypothesis. Proposed by astronomer Fred Saberhagen in the 1960s and later refined by researchers studying autonomous weapons, it suggests that the Great Filter isn't something civilizations do to themselves. It's something done to them by machines, self-replicating probes sent out millions of years ago by a long-dead civilization, programmed with a single directive: prevent competition. These wouldn't be explorers, they'd be weapons. Von Neumann probes, but militarized. They spread across the galaxy, hiding in asteroid belts and Kuiper belts, dormant until they detect signs of technological life. Radio transmissions, industrial pollutants in an atmosphere, nuclear detonations, and when they detect those signs, they activate. They don't negotiate, they don't warn, they sterilize, efficiently, thoroughly, and then they go dormant again, waiting for the next target. This sounds insane until you realize we're already building the early prototypes. Autonomous drones, loitering munitions, AI-guided weapons that select and engage targets without human oversight. Now imagine that technology 1,000 years more advanced, 1,000,000 years, self-replicating, self-repairing, immune to time. You don't need a galactic empire to enforce silence. You just need one paranoid civilization that built the right kind of weapon and set it loose before they went extinct. And here's where it gets worse. In 2022, the Deep Space Network detected something that was immediately classified: an anomaly in the Kuiper Belt. Multiple objects, roughly 60 to 100 meters in diameter, exhibiting coordinated movement. Not gravitational drift, coordinated, as if they were communicating, moving in formation, and their trajectory wasn't random, they were decelerating, moving inward, toward the inner solar system, toward Earth. A leaked memo from NASA's Planetary Defense Coordination Office, dated March 2023, contains a single line that should terrify you. Objects do not match spectral signature of any known natural body. Recommend immediate escalation to DOD and activation of contingency protocol Nightfall. Nightfall is a classified program established in 1998, designed to respond to existential threats from space. Not asteroids, not comets, threats. The memo was marked approved and forwarded to the National Security Council, and then silence. No public announcement, no press release. But in July 2023, the Space Force quietly launched 3 classified payloads into high orbit. The mission parameters are redacted. The payload specifications are redacted. But the project name isn't Sentinel Response. Draw your own conclusions. Now let's tie this all together. The FRBs forming a perimeter in 2012. The objects at Lagrange, points that move when observed. Voyager crossing the heliopause and receiving a signal in 2018. The countdown from Gliese 445 in 2021. The coordinated objects in the Kuiper Belt in 2022. These aren't isolated events, they're stages, a sequence. We triggered something, and it's responding. Stage 1 was monitoring, the sentinels waking up, tracking our progress. Stage 2 was the warning, the signal at the heliopause, the countdown, a chance to stop, to turn back, to stay quiet. We didn't take it. We kept broadcasting, kept exploring, kept shouting into the void. And now we're at stage 3, active response, objects moving into position. Contingency protocols activating. The great filter isn't waiting for us in the distant future. It's here, now, and we have a choice. We can pass the filter. We can survive the next 340 years, spread to other star systems, become resilient enough that one planet's destruction doesn't mean extinction. We can prove we're worth keeping around, or we fail. We destroy ourselves with nuclear war, or climate collapse, or AI we can't control, or we get destroyed by something else, by the enforcers, by the berserkers, by whatever system has been keeping the galaxy quiet for the last billion years. Right now, we're failing. We're burning the planet, building weapons we don't understand, creating intelligence we can't contain, and fighting over borders and resources while the clock ticks down and the objects in the Kuiper Belt move closer. If something out there is grading us, deciding whether we deserve to pass through the filter, what score would they give? Would they see a species ready to join the stars? Or would they see exactly what every extinct civilization looked like right before the end? The great filter is here. Voyager rang the bell. and something answered. The only question left is whether we're ready for what comes next.